Alrighty. Um. Today I'm just going to be doing a fun little derivation of the quadratic formula. Much isn't required to know how to derive it. All you need to know is just how to complete the square, and let's just get into it. So we have this polynomial where a, b, and c are all coefficients. Uh, I'm not gonna get into that whole spiel of they could be imaginary or real, because it just depends what solutions you want. But let's get into it. All right. First, an important step we need to know when completing the square is our a must be equal to 1. Okay? A must equal to 1 when we're completing the square. So in order to get a equal to 1, what we're going to have to do is factor out an a out of our polynomial. Okay? So if we factor out an a, we can get x squared plus b. Oh my gosh, let me draw a better b. B over ax plus c over a. And since this is equal to 0, we can just get rid of that a. And so now what we're left with is x squared. Shoot, let me draw that x squared better. X squared plus b over ax plus c over a is equal to 0. Now we can actually complete the square because the coefficient attached to our x squared is now 1, which means this is doable. So to complete the square, the formula is you want to take our b coefficient. The general formula is b over 2 squared, right? We're going to take b over 2 squared. And then say we have this practice quadratic. It would be plus bx, right? We're going to add our b over 2 squared and subtract our b over 2 squared. Because now, when we factor this, we see that what multiplies to b over 2 squared and adds to b? B over 2. So now, what we can do is we can say that this is x plus b over 2 squared, right? Plus c minus b over 2 squared. Or b squared over 4. And see, this is how we're going to derive our quadratic formula. So let's go back and let's just use it. Let's use completing the square in the context of our polynomial that we derived. Oops. Okay. So we're going to take our b over a. So our b coefficient is b over a. So we're going to do b over a divided by 2, which is just equal to b over 2a, right? And now we're going to square this. So we're going to square this. B over 2a squared will give us b squared over 4a squared. Okay? So now what we'll do is we have b squared over 4a squared. So now what we're going to do is we're going to do x squared plus b over a x plus b squared over 4a squared plus c over a minus b squared over 4a squared is equal to 0. And this works because these cancel out. These two cancel out because we're not changing the polynomial. We're not adding anything new. We're basically adding 0 because these terms will cancel out. But now what we can do is we can combine these terms, which we can do by just some simple just multiplication to get 4a squared in our denominator for c over a. We're going to have to multiply the bottom by 4a, so we get 4a over 4a, and we get our new denominator should be 4ac over 4a squared. Okay, so when we do that simplification, we get x squared plus b over ax plus b squared over 4a squared, right? Plus 4ac minus b squared over 4a squared is equal to 0. So now let's subtract this term to the other side. And I'll show you why we're going to do that in a moment. Okay. Let's get rid of all of this so we have more space. Okay. So now we have x squared, right, plus b over ax plus b squared over 4a squared is equal to the negative, right, of 4ac minus b squared over 4a squared. Well, let's get rid of this negative and let's factor out a negative out of this. So when we factor out a negative out of our other side, we get negative of negative multiplied by b squared minus 4ac over 4a squared. Our negatives will cancel out, and so now we are just left with this. B squared minus 4ac over 4a squared. Okay, so now let's factor this, what we have on this side of the equation. So what multiplies the b squared over 4a squared and adds to b over a? Well, I'll save you the thought process, and it should be b over 2a. Because if we multiply by itself, we get b squared by 4a squared. And if we add it, we will get b over a. And if that's a little hard to see or a little hard to understand, I could put it like this. So we'll see that this is essentially the same thing as b over 2a, right? 1/2 times b over a. And if we add that by itself once, we're going to get b over a, which is our b term in our polynomial. Okay? So now we can say that this is just x, x plus b over 2a, right, squared is equal to b squared minus 4ac over 4a squared. And so now we can solve for this like it's a normal equation. So we can square root both sides. And in this circumstance, when you square root both sides, this side will be plus or minus. So now we have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. Okay, let's erase what we have up here. Okay, so now we have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over over 4a squared, right? And we can actually simplify our denominator here, and we can take this out of the square root because this is just 2a, because if we multiply 2a by itself, we will get 4a squared. So now we can rewrite this as x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 2a. And now we can solve for x by subtracting our b over 2a on both sides. And since both of these have a common denominator, we don't really have to do anything to this b over 2a. So our final result will give us x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's our quadratic formula. Well, thank you for watching this derivation, and have a good day.